Good evening. Welcome to Operations Management course. I'm Dr. Rao Khan, and we'll be covering design thinking. So let's talk about design thinking. Design has a business strategy. What does that mean? Because products and service design touch every part of a business organization, from operations and supply chains to finance and marketing, accounting, and even information systems. Design decisions have far reaching implications for the organization and its success in the marketplace. Product and service innovation is becoming a key avenue in pursuing a competitive edge, and sustainability issues are being given increasing importance in business decisions. So, design thinking is not an exclusive property of designers. In fact, all great innovators in literature, art, music, science, engineering, and business have practiced it. So, why call it design thinking? What's so special about design thinking is that the designer's work processes can help us systematically extract, teach, learn, and apply these human centered techniques to solve problems in a creative and innovative way in our designs, in our businesses, in our countries, and even in our lives. When design becomes that guiding compass for our company's overall strategy, the benefit is being able to clearly define who your target audience is, what they need, and how you can create value for them. Your product approach isn't going to be just a shot in the dark, a trial and error experiment. Instead, you'll have a researched backed product upon which you'll be able to iterate it, keep improving it, making changes, and make that product better than when you first started working on it. So design thinkers rely on customer insights that are gained on real world experiments, not just historical data or market research. Okay, to continue our discussion from where we left off, we just finished talking about design thinking has a business strategy for product development. Now, let's turn our attention to research and development process. Now, a lot of people do make that mistake of using product development and research and development process interchangeably, but they're not one and the same thing. In fact, the difference between research and development and product development is that research and development, right here under this orange bubble, is actually the beginning initial stages of the entire product life cycle. But when we talk about product development, we're talking about the whole process of of designing the product, creating the product, marketing new products, or even adding new features to existing products. So one subsection of product development would be research and development, but they're not one and the same. So research is another source of ideas for new or improved products and service. Research and development really refers to that entire organized effort or framework where you're directing increasing scientific knowledge, product or process innovation. And most of these advances, anything from semiconductors to medicine, communications, and space technology, can be attributed to R&D efforts at the college and university level, at research foundations, government agencies, and even private enterprises. So research and development efforts may involve basic research. It may even be applied research where you have a concept and you test it and create a prototype, or it could be something that involves development. So basic research has the objective of advancing the state of knowledge about a subject. When I say basic research, it involves writing academic journals, letting the academic community know about your idea, and publishing them. But you may not do an actual experiment to back up that study. It's just publishing an idea without any near-term expectation of having commercial applications. Whereas in development, when we talk about development, we're taking all of those results of an applied research and then putting it into some useful commercial applications. So, for example, we have You've probably seen some of the foam mattresses and you've seen the foam pillows. Well, at one point, they all stemmed from space technology. And so, after much research, it was deemed that yes, this is safe to be using in every day-to-day life. And that's how we have so many other inventions, but one of them being the memory foam mattress. And so that would be an example of development, whereas the space research would be R&D. They had a new concept, they found foam, they didn't know what its applications could be, but then after experimentation, and they didn't have any intention of making foam, this memory foam, to be something that would be used on a daily basis. But now we have manufacturers using memory foam to create comfortable beds and really nice pillows. So it's interesting to note that some companies are now shifting from a focus primarily on products to a more balanced approach that's going to explore both product and process R&D. Also, there's this increasing recognition that technologies often go through these life cycles the same way that many products do. So that's going to impact the R&D efforts. Sustained economic growth is going to require constant attention to competitive factors over the entire life cycle of a product. It also means that we have to be ahead of the game in planning to be able to participate in the next generation of technology. So design thinking is increasingly being seen as a means to enhance the innovativeness of R&D. So another point of crossover between R&D and product development is design thinking, which is the very reason we have included design thinking in this module. So corporate research goals share many of the challenges of design, things like speed, originality, viability. The similarities of purpose with the corporate scientific R&D and designers are so remarkable, suggesting that some of these approaches of design thinking could apply to the scientific community. So design thinking so far historically has been just thought of as a concept that could only be applied in the development phase, mostly in R&D, that it was something more operational. But now we're finding that it can be, design thinking can be applied to R&D and be part of the innovation pathway. So what does corporate R&D learn from design thinkers? Great question. Traditionally, design thinking has primarily had their application in the product and service development. It hasn't been much applied or experimented with in the traditional corporate scientific and technical research. So by adapting some of the insights and methodologies from design thinking, a modern scientific R&D organization may have the potential to increase their speed, be more inventive, and vitality of their output could become this explosive engine of growth. So the current thinking by most of the scientific teams is that progress can only happen if you have a different model of work, and that work has to be based on an intense knowledge about a very technical domain, and that requires, a rigorous process of testing that's also based on scientific method, and the scientific method meaning, involving testing hypotheses, having controlled experiments and things, and it has to be communicated through peer-reviewed journals and magazines to ensure that there's integrity of the whole concept. So the model has its roots in academia, and it supports that respected model of scholarship. But in the traditional framing, where main activities and resources were driven by R&D and a technocentric view, design thinking was dismissed. Hey, that's just an operating activity. It's only involving how to improve how a product looks, its aesthetics. So let's take a deeper dive into exploring how design thinking could possibly be used in research and development. Design thinking is conceptualized as multidisciplinary, iterative, and a human centered approach inspired by designers that led to transformation and innovation. The human centeredness concept that's in design thinking means what drives the entire innovation process is the identification and satisfaction of users' needs. Human centeredness in itself within the design thinking concept is achieved by the innovators exercising empathy with the users. Empathy means a willingness and ability to adopt to the perspective of other persons and recognize their perspectives as the truth, and to be open to various inputs, to suspend judgment, not to dismiss users that because they don't have a rich scientific knowledge, which is what most of traditional R&D development experts have done. They have never really thought that someone who's outside of the technical scientific world would have much to contribute to product development. And sensing their emotions communicate by mirroring back is the other part of human-centeredness. So the way the innovator puts herself in the user's shoe is by conducting an ethnographic research. Ethnographic research means you're going to study the preferences and likes and cultural aspects of the people who the product is intended to be marketed to. So by immersing in the user's natural habitat, replicating and observing the user's behaviors might reveal thoughts and feelings, might even question motivations through a deep contextual interviews to infer an intangible meaning of some of those experiences. Now, with manufacturing and service sectors, ethnographic techniques from design thinking concept could reveal issues with the existing product. It could facilitate understanding of the customer attitudes, perceptions, and needs, both rational and emotional. So a good example of that was when BMW BMW came out with these minivans. And Americans, when we buy minivans, we really like to have large cup holders. And it's almost to the point that no one will buy it if there aren't multiple cup holders, because a minivan is usually the vehicle preferred for going on long family trips. And this was specified when BMW engineers who were in Germany were asked to design a minivan. What happened? They were like, "Oh, that looks so ugly. All these little holes all these multiple holes there." So when these minivans showed up in United States, and they had a hard time selling them. The first question they asked, how many cup holders does it have? And then when they looked inside, they saw no cup holders. That was the end of the discussion. Customers and people did not want to further explore BMW as their next minivan purchase. So this is where a good example of how design thinking would have given them ethnographic research knowledge to be able to not just produce a product for the sake of producing a product, but keeping in mind the consumers are the end goal, and taking into consideration what their perspectives are, and also what the American consumer would consider to be priority in their sales purchase process. So the value that customers perceive may be decided by many things other than just the technical innovation. Just like in my BMW example, people aren't going to just buy it because it says BMW and it's German. Whereas, of course, the German engineers in BMW thought, it's BMW. Wow, what is your problem? Don't you want BMW? Why would you care about cup holders? So things, for example, usability. That's where the cup holders was an example. Why, if you can't drive down the roads singing a beautiful song with your family and not worry about your Pepsi or your favorite drink spilling over, then that defeats the purpose. Or even serviceability, the cost of the use, and so on, and have to be integrated in the existing workflows. So customers also frequently choose products, even highly technical products, for emotional reasons. For example, they may be afraid of being left behind of the Joneses, a fear of change. For example, we might buy an Apple phone over a Samsung because that's a display of status or a brand identity that we associate with. So design thinking, with its empathetic, intuitive, and explorative approach, can connect researchers closer to their targeted human users. So design thinking is experimentation based. Experimentation in the context of a innovation process means using prototypes, and prototypes are incomplete or approximate representations of the innovation output under development to actively intervene on the reality and manipulate it. So testing prototypes with target users serves to create a realistic experience on what the innovation might be so that the users can provide reliable feedback. And such a feedback is going to be fundamental for innovators to make that accurate design decision as the product unfolds. So, for example, when people go to order a new car at a dealership, that's why they have these basic model cars in the showrooms. And after you've driven everything, then you customize your car. That and the customization option that is offered by car manufacturers is exactly an example of design thinking. So whereas research and development would be, here's the basic car, has a working motor and the basic features that we would offer to you, but we don't know what you would like in terms of color. And that's where we invite consumers to come to the showrooms before they finalize their purchase, drive it, and indicate what their preferences are in terms of the size of car that they need, drivability, any other specific features, leather versus maybe vinyl, or even cloth versus sheepskin. Who knows? You can go as crazy as you want in ordering a car, right? That's an exciting time for most people. So the success of any innovation depends on simultaneously achieving that user desirability as well as the technological feasibility, and together, not only does the design have to be perfect, and it also has to have all the hoots and whistles of technology, but it has to come at a price tag that's affordable to the common consumer. So design thinking almost prescriptively instructs innovators to address desirability first, because there's no point in creating a product that no one can afford. There's also no point in creating a product that is so technologically savvy, but yet nobody knows how to use it. And lastly, even if you create something that is affordable and is high tech, if it looks ugly, no one's going to want to buy that, right? That's what design thinking is essentially saying to us. So by continuously involving end users in this iterative co-creation where we create the basic model and we continuously make the changes so that it will meet the vision of the consumer, and testing these ideas and prototypes, design thinkers can ensure that the outcomes of their innovation effort add value to the human experience, and they're meaningful, but most importantly, they have to be affordable. Okay, now let's take a deeper dive into the concept of product development, since we've just finished covering R&D, research and development. Until recently, design and businesses have really never sat at the same table. Some believe that designers are just asked with making things look pretty, right? Put some bows on it, it looks good. But nothing could be further from the truth. Design thinking is where the business strategy gets integrated with the targeted users. So product design is that whole process of accomplishing business objectives through creating these user experiences so that the user will feel emotionally connected to that product. So just like if you do 3D video games, if you go try that 3D video game as opposed to just it arriving at your house and opening the package, you're going to be more likely attracted to that product, and you'll probably even buy it at a faster rate. So, and also it's about creating trust and validating features that the users will use, and you're championing your users' needs. So product development can be creating a new product or even a different product that's going to offer new benefits to that end user. And this could include, either modifying an existing product or you're creating an entirely new product. So these changes or new introductions may be even targeting a whole different customer requirement, or even it may be just focused on catering to a niche category of people in the market. So, for example, maybe you're creating an innovation that helps people who are disabled. So, that would be an example of a niche market. Or maybe you're taking the iPhone and you're going to add another feature where it can be used as a projector and you could watch movies out in the park with your family. So, a product can be defined as a collection of benefits that can either be tangible, such as a physical item, or intangible, like a service or an experience. So, your iPhone gives you the experience of being able to watch a movie. You can make a phone call, you can text. It's not just a phone. You can even type letters and send emails. So, it's a communication device, an entertainment device, a gaming device. It gives you so many features. So because time has kind of become this competitive weapon, there's a lot of pressure on businesses to have a project-based new product development organization. And so those pressures have led to this explicit understanding that we have to produce products in a shorter amount of time and get them to market quicker. So therefore, traditional methods of sequential production haven't been able to compress the time between development to market. So let's talk about as the sequential design process. So in product development, there's two flavors of how you could have a design process. It can either be sequential or it can be concurrent. We're going to focus on sequential design process. That's the traditional engineering, where the process of marketing, engineering, and design and manufacturing, testing, and production were each a stage of the development process, and they were conducted separately, where one stage had to be completed before you could start the next stage. So in my image here, it would be creating the design, then it would go through a process planning, and then after process planning is completed, it would go into manufacturing. But there was how traditionally things were produced is that there was no thought that you could even conceivably do process planning before the design was complete. So traditional sequential engineering is a term that's been used to describe a linear development process where design and development steps are carried out one after the other, focusing on the field of expertise at that point in the production process. Now that companies are looking for ways to get the product in the hands of the consumers at a faster rate so that they can outcompete other companies, then there's been a focus and an exploration of having a different type of design process method. Because with the traditional sequential design, there are definitely some pros and cons in it. It's not something that you would rule out. So if you were going to follow the traditional sequential design process, since everything is done has one stage having to be completed before the other stage, if you wanted to make even a small change in the later stage, that would end up delaying the time that the product would leave the manufacturing process and be in the hands of the customer. Also, if it was a defect was found in the later stages of product development, now you've spent all that money and you have to scrap it and start over from the beginning. So this approach resulted in a large number of modifications and alterations in the later stages, and it turned out to be very expensive, especially if you're dealing with $1 million project. So you can still use sequential design process for simpler products that don't require a lot of overlapping collaboration. or don't really require a lot of multidisciplinary collaboration. And so this sequential engineering method is easy to track because if you have any bottlenecks or any underperformance, it's very easy to work backwards and find and pick out where the weakness is in the process and then rectify that. So a highly complex product line that was made simple, fast, and efficient. But of course, issues always are going to arise. If one of the departments, for example, makes a mistake on their assigned task, then the product has to go all the way back to that assigned task. And the product would have to go over that whole wall of rectification. This is called reverse flow. And it's one of the major reasons why traditional sequential design process is considered as being inefficient. Now, of course, we're going to touch upon lean concepts. Lean concepts and sequential design process tends to be a concept that many students get confused, but they are not the same. Lean design process really focuses on maximizing the customer value while removing any wastes that are not adding value. So they're really looking at process steps rather than looking at how, the consumer's acceptance of the product is where the key difference lies. That brings us to concurrent engineering. So at the top here, you see this is the traditional sequential from process design, and you can see if requirements are gathered. Then from the requirements provided by the consumers, we go into assimilating a design. Then we go to the implementation process. So each stage from requirements has to be followed through before you can go to the next stage. Now, concurrent engineering, you can see that there's areas of overlap. So it's a different type of approach to the design process. So it's a long-term business strategy where tasks are done in parallel as opposed to in sequence. And one of the benefits is that you get early consideration for every step in that product development process. So this strategy is really focusing on optimization of the firm's resources. And it's, as you can see here, that because of that overlap in the steps in the design process, they're able to actually shorten the time between the production of that product and the time that the product actually hits the market and gets into the hands of the consumer. So that's one of its biggest benefits. So, and second benefit would be that there's less wasted because you're going to check at every stage if there's any defects instead of waiting at the end of the production line to find a defective product or a defect within the process itself. And so the design and development process, I have to consider all the elements within the product cycle from concept to disposal and the quality, the cost, the schedule, and even the user requirements when you're doing concurrent engineering. So in this methodology, several teams within an organization are going to work concurrently to develop the products and services. So the product design, the quality, the unit cost, and the manufacturing time are all the parameters that will be continuously monitored and so that it will bring in profitability to that organization. So it's a way of improving these factors and providing companies with a competitive edge.